In this video, we're going to learn how to adjust the files provided by opentopography.org so that they're useful as input data in the Mathematica codes that I use in the search for the ground surface trace of faults that can generate damaging earthquakes. Now, I'm counting on you to use the pause button and navigation slider on your video app when you want to read or review the contents of this video. After we have extracted the data that we want from a data file on opentopography.org, we download a file called rasters_sdem.tar.gz to our computer. And this is a compressed file, and we need to take a look at the process of decompressing it and making it useful. So here are three of the files that I've pulled down from the opentopography.org site. And the one in particular we're interested in is this rasters_sdem.tar file. So I can decompress that by double-clicking on it, and you can see a folder has been generated here. Now right off the bat, I'm going to rename this folder so that it has a recognizable name for this particular analysis. Okay. Because when you pull down lots of these, God damn it. So here are three of the files that we derive from our extraction process at opentopography.org. The one that we're particularly interested in is this tar file, this compressed file. To decompress it, we just double click on it, and that gives us a folder here. First thing I'm going to do is rename this folder so that it doesn't get confused with other download files from opentopography.org. Rename it something that will make sense to me tomorrow morning. Open it up and see what we've got. These three documents are the documents inside that file that we just decompressed. And the first one is output_be.asc. Now this is the file that we're going to want. It's the file that has the digital elevation model in it. It's an ASCII file. It's got this sort of funny little ASC ending to it. What I'm going to do to start with is I'm just going to change that ASC to a different ending, TXT. Conventional text file. And when we open up that file as a text file, we can see what's inside. And it turns out what's inside is a bunch of numbers. The file itself is a big matrix of numbers with 6 header lines at the top. And those header lines tell us the number of columns in the matrix below, 5,050. The number of rows, 2,100 rows. The UTM coordinates of the lower left corner X value, the lower left corner Y value, the size or the spacing between the individual elevation data. So the cell size is 1 meter. And then the last of these 6 notations is telling us what the value that's inserted in the matrix if there's no data, the no data value. Right below that is the very first of these elevation data. And this one is 1880 plus a lot of numbers to the right of the decimal point. This particular datum, the one that is in the first row, first column of the data matrix, is important in the code to create a hillshade image. And in fact, it's the one that controls the amount of contrast in the grayscale of the image. So based on prior fiddling, I put in the number that gives me the most pleasing and informative grayscale on my ultimate image, which I have found to be 1500 for this particular data set. So I'm replacing that one bit of data with a different number. And then I'm done. What I do now is I just save it and then close it. And I'm going to come back up here and change that text extension to a DAT, D-A-T extension. And now I've got a DEM, it's an ASCII DEM data set that is in the correct format for me to use both in the SLAM code as well as in the Hillshade code that I've written in Mathematica. So that's all there is to it. If you have any questions about the contents of this video, please drop me a line. It's Vince_Cronin at croninprojects.org, and I'll try and help you up the learning curve.